Again, if you're
All right, Chris,
if
we're
you
live, sounds up, and then we're recording.
very good. Hello, everybody, and welcome to another DIY RoboCars virtual race. Today we have a special race for two reasons. One is we have a lot of racers, which is not that unusual. But the second is that we have a presentation from the winner of the Indy Autonomous Challenge real race that happened just a few weeks ago. And we'll have about the first 10 minutes will be a presentation from them, and then we'll take some questions, and then we'll dive right into the virtual race. So to introduce, well, first I'm going to start with our hosts here today. As always, we have Jack Silverman from UCSD, who many of the racers are his students. Jack, good morning. What's new?
Good morning, good afternoon, good evening, everyone. We're back to one of our favorite race tracks. That's the mountain track. Maxime should take all the credit to bring it back to life. We still have to optimize a couple of things to have 4 cars running, but we're gonna do 2 by 2, and it's a pretty fun track. And I think the folks on F110 will be able to join us next time, because with the walls, the LiDAR sit all over, and they should be able to navigate here too. That's about it, Chris.
Very good. Well, behind the scenes are the technical geniuses, Maxime and Dimitri, who are responsible for creating the simulation and all that goes behind it. Maxime, good morning or good afternoon. You're in Paris.
Good afternoon for me. Good morning for the people in the US, and good evening for the people in the other part of the world. So yeah, this time we have a new track. I mean, new. Not really new. We had it previously. I think maybe one year ago. So yeah, it's a comeback of the mountain track that I really like, and we are having some little issues performance-wise and optimization-wise. So we will be only running 2 people on the track, but it should be really fun. So I look forward to it.
Thank you. Dimitri, is there anything you want to add to the technical architecture?
Not much. I'm happy to see everyone, and I also happy that we have a lot of competitors running the Docker containers, which is very cool because we reduce the latency. So yeah, let's see how it goes.
What is this Docker container you just mentioned, Dimitri? Why do we need it?
Yeah, basically we have a virtual environment here on the server, and that helps people to run their cars inside the virtual environment on the server. That's how we reduce the latency, because we eliminate the network latency between your personal computer and the server, because everything is running inside the containers, inside its virtual environment on the server.
This is really important because it some people were at a disadvantage before because they were in Japan or far away, and the way it works is that the simulator is generating the virtual images, and then the code that your car is using to interpret those images and turn into commands is running on people's local computers, and then they send their cars send those commands back to the simulator, which then makes a virtual car behave according to those commands. So basically it's imagined if you had like a regular car, and in the real world, it would have a camera and it would have a computer, and they'd be right next to each other. In this case, we've separated the two, the cars in one part of the world and the cameras in another part of the world. And if there's any latency in the communications between them, the car ends up steering to where it was a second ago rather than right now, and it becomes extremely hard to manage. So Dimitri's Docker container is a way to have basically the car's software running locally at the same time, as you will, as the simulator, to avoid the latency. I probably mangled that a little bit, but that's I think that's probably the right idea. Jack, did I more or less get that right?
I think you got that very well, Chris. Very
Thank
nice.
you. All right. Well, with no further ado, I'd like to introduce Alex Polonsky from the Detroit chapter of DIY-RoboCars, which has always been a big a participant in both these races and their own local physical races. Alex had the privilege of being able to be part of the Indianapolis Autonomous Challenge this month. And Alex, over to you. Tell us more about what you saw, how you got involved, and introduce our guests.
Thank you, Chris, and welcome everybody. Those of you who are coming back, welcome back again. And those of you who are new to this, I think you'll really enjoy this. Today we have a very special guest from Polymove. The way we met was, I'm actually part of the Parking Lot Nerds team with Rainer, who is in Germany. I'm in Detroit, like Chris mentioned. And in October, at the very first race in Indianapolis, we got invited through AutoWare to demo some of our C cars and kind of build the connection between the small cars and the big cars, which I thought was very, very interesting. And while there, we were trackside and I was walking in the pit lane and I came across Mustafa from Polymove, and our passions kind of aligned. We just got to talking. And in Indianapolis, unfortunately, they had a crash, but they ended up winning at CES a couple of weeks ago. And so today, I think this is a perfect opportunity to share what simulation can do to help you prepare for the real world. And at this point, I will hand it over to Mustafa and Filippo from Polymove. Guys, thank you for being here. Thank you for joining. And over to you.
Okay. Alex, thanks for having us. Filippo has a nice presentation that we can share together.
Okay, let me see.
About a little background first. What are you guys from? What is Polymove?
Yeah.
What's up with this name?
Wait. Let me do
so
like this.
We're
wait a minute. No, I just want to check if the presentation is fine. Can you guys see the screen?
Yes, now it's perfect.
Okay, cool. Go on. I didn't want to interrupt you.
So we are. I'm Mustafa. I'm a team member of Polymove Autonomous Racing Team. So we are basically an autonomous racing team which was founded inside Politecnico di Milano with our team members last year, after we saw that there is a competition in the Autonomous Challenge. Our professor decided to create a team for especially this task, and we are the team members for it, and Filippo is our junior team lead. Filippo, you can go on.
Oh, you want me to go? Okay, that's fine.
Yes.
So yeah, actually, I prepared just a few slides. I don't want this to be an actual presentation. I would like this to be more of an informal discussion because I didn't really know what you guys were most interested in. So yeah, this is us. This was the picture taken, I think race day or maybe the day before. I don't actually remember, at IMS. I put just quickly, not to brag, but just to show you guys what we achieved in 1 year. We went through a sequence of simulation tests. It was last year, starting from January, actually also the year before, starting from October 2020. Yes, 20. Yeah. There was this sequence of hackathon, this sequence of simulation events, which let's say ended in June 2021, when there was this simulation race, head-to-head simulation race, which we ended up winning, but we'll talk about this later quickly. And then there were two real events with the real car. We had something like, I think, around 30 teams attending the, let's say, or subscribing to the event in the beginning. That got narrowed down to, I think, 15 or something for the simulation race. And then we ended up being 10 teams participating to the event with the real cars at Indianapolis in October. We got, this is wrong. I put a second place, which is actually a third place. My bad, sorry, I was not trying to cheat. This is actually a third place that we got because of a crash that we'll talk about later. So we were a little bummed after this third place because we thought we kind of did everything. I don't want to say everything right. I don't know what we would have ended up, I'd say, getting if we didn't get the crash. But we surely know that we didn't show everything we could do. So let's say we rolled up our sleeves. So we kept working, and a few months later, we managed just a few weeks ago to win the second round of the competition, which was in Las Vegas this time, which was a big satisfaction because it was actually a head-to-head competition with multiple vehicles actually really on the track. So here I have just a few snapshots, a few small short videos of what happened in June 2021. So this was the simulation race. Actually, I gotta say, I don't know much about your community, guys, but from the 10 minutes of discussion that I heard, you guys are amazing. I don't know if Mustafa is of the same opinion, but
Yeah.
I don't know from what I heard from the type of things that you guys are doing, where they are incredible and probably much better than what we ended up doing in this simulation race, which I gotta say was a little bit of a pain in the ass because I mean, it was really difficult to I don't know, to set up the whole simulation and to actually make it work with yeah, the environment and all. But if you guys have questions, we can answer about them later. All in all, what we did was work pretty much, I think, 8 months or something on the code. The simulation was let's say, especially from the perception point of view, was really oversimplified. All the vehicles had almost perfect knowledge of the position and velocity of all the surrounding vehicles. So it was pretty much focused on planning. So develop the planning algorithm or the planning part of your algorithm to handle head-to-head racing. From that point of view, was actually quite an interesting and useful experience. And yeah, also for the vehicle dynamics, this was, I mean,
it was not that bad.
Yeah, it was not that bad. The model itself was pretty complete, I would say, mostly. Yes.
Yeah, I think so.
Yeah, it included, in the end, it ended up including also some slipstream modeling. So we had friction models. It was I mean, I think Mustafa can talk about this in more details if you guys want.
Yeah.
But it was an okay model, I would say. But of course, then I mean, porting everything to the real world required to solve a few challenges, non-trivial challenges. So the simulation actually played a big role in our let's say in the development of what we did. That simulator that you guys saw, this was developed by Ansys, was the official simulator. It's called the VRX. To my knowledge, this is not actually a racing simulator. Let's say it was not created as a racing simulator. It's more of an urban driving simulator. But they worked a lot during this event to actually make it work as a racing simulator. So we were using that as our final simulator for the competition. But let's say in parallel, we developed 2 different type of simulators that we also used to develop our code. We had a MATLAB simulator just to, let's say, develop the planning strategies, to check everything real quick and to to plot stuff when you do everything in MATLAB is a little quicker. And then we had another simulator that proved to be very useful, which was an hardware in the loop simulator, in which we had this speed goat real-time computer in which we were running a model of the vehicle. And we had an hardware in the loop with a copy of the computer or something similar to the computer that we had on the real vehicle, in which we were running the code real time to let's say, have a final validation of the code before actually putting it on the real car. Ooh, these were videos. I didn't remember. Okay, so I'm gonna let's say be very quick. They asked us to talk a little bit about what happened here. So here we felt very strong and we were going for our final race. This is IMS in October 2021.
This is the Indy race, yeah?
Yeah, this is the Indy race. And okay, here we hit the wall once, then we hit the wall twice, and then a third time, and people kept asking us why we hit the wall. The reason is that basically we lost completely control of the car, and I'm not talking about vehicle dynamics, I'm talking about actual control. Like basically what we had was an overcurrent problem. One of the system of one of the low level control systems was not designed, let's say, properly. I can go into more details later if you guys want. And basically detected an overcurrent because we hit a velocity that was never tested before. Yeah, that's mainly the reason. And so basically when that happened, that specific ECU decided to cut the power to the whole vehicle and to take control and to cut us out of the control of the car. So from that point on, we were not actually controlling the car, and the car was just putting a straight steering and kind of trying to brake. And pretty much that's what happened. So we were bummed. We studied the issue and we tried to fix it by changing, let's say, basically the thresholds that were triggering the event, and by changing how the fault was managed, meaning that when that was, let's say when that happened, instead of our controller being completely cut off of the loop, we made it so that actually we were in control of the car the whole time. So even if the problem was still happening, at least we would have kept having control of the car until to drive the car to a safe stop properly. And this is Yucca in Arizona at beginning of December 2021, when we did our attempt to the speed record. This is I mean, it's a huge proving ground. I think is owned by Stellantis or something. And what we did here was to do a few fast laps. We reached a speed of 175, I think, miles per hour, which barely scratches the surface. Let's say it barely scratches the limit, the speed record. I wanna stress this. This is not an official speed record. It's not an official attempt to award record. Let's say how you which is still held by the RoboRace guys. So I don't really like this video that much. We didn't make it. The IAC guys did it, and yeah, here they say this is a new record. That's not really true because we barely touched the limit and we didn't keep it for long enough to actually, let's say, for this to actually be a real official record. The reason why I put the video is that here we still had the problem. The reason why we didn't, let's say, go higher than that was not that we didn't have enough power or something, but just because I don't know, luckily enough, at 175, we were hitting again the same issue. So in December, we were still having the issue. We worked a little farther, and a few weeks later, basically in January, we were able to do this, which was achieving an overtake at 170 miles per hour. Again, our fierce German opponents of the Technical University of Munich. And here they spun. They had a, let's say, controlled spun during the last overtake attempt. Again, we were going 170, they were going 150 for the rules of that specific attempt. And that's how we won the race. Yeah, I mean, I think basically in terms of preparations, these guys were incredible. Like the type of control of the car that they had and the type of, or the level of the perception and planning, as far as we could tell, was incredible. I think that part of the reason why we won is that we had that issue in October, and so we worked a lot on the reliability of the car and how to handle all the possible issues, so that in the end we were a little more free to push the car to the limit, because we knew that even if we got over the limit, we would have been able to handle the car. So I would say that's it. I have a few schematics that I can talk over if you guys have questions, but I don't want to, let's say, continue and talk for too long. I would rather have you guys have answered to questions if there are any or something. I don't know if this is okay for you guys.
Can I pose one, Chris?
Yeah.
How many people do you have in your team, and what is the kind of composition, like industry, university only? And if it's university only, how many students and what's their level of education?
Yeah, so this is close to the whole let's say boots on the ground team. Yeah, this is the team that worked. This is the core team that worked on the competition for the most part, and it's 100% university. Just because the type of competition required the team to be a university one. So I think they did that to, let's say, jumpstart the competition. But starting probably from the next event, which should be in the fall of 2022, I expect many teams to go, if not professional, semi-professional. I know that the Germans and the other Italian team have some sort of plan in that direction. We for sure have a plan in that direction. So to create a spin-off and to create a professional or semi-professional team. But yeah, these are all students. We have, I would say 70% probably are PhD students. I am a PhD student. Mustafa is a research assistant, which is, I mean, comparable in terms of experience to a PhD students. We have a few master students. In this picture, I think we have 3 or 4. Yeah, and we had two senior professors following us. One is Sergio Savaresi, the one on the right. Which is the Italian professor, actually is our team leader, and the other one, the one with the hat, is Brandon Dixon, which is actually also a race driver. He is a national champion. I don't remember exactly what he won. I don't know if you do, Musti, but he's a race. Yeah,
he drives open wheel cars in semi-professional races.
And he has a big experience. He was very useful to actually win the thing. And in terms of what we study, I think 80 or 90% of the people here have an automation and control technical background, at least the Italians. Mustafa is actually
I'm a mechanical engineer. And Cole is also a mechanical engineer. So our focus were more on vehicle dynamics, and maybe more detailed simulation analysis of the handling of the car. Whereas my teammates were more based on the control theory and designing the estimators and control algorithms of the car.
Right. For the UCSD students, in comparison, how many PhD students we have from UCSD master students on the race?
You mean all the teams or
no,
yes?
I'm talking about for the UCSD students, 0. We have 2 undergrads.
You guys.
It's talking there. Yeah, so we are really underdog here. It's a whole other story about that. I think this is a lifetime opportunity for those of you that got excited about this presentation. Come talk to me. We just have a 10-page exam in C++ and simulation ANSI, and if you pass that 10-page simulation and coding, and you win the team. Just kidding.
Rainer had a question about, he said, can you detect with your sensors when the car is close to leaving the friction cycle? In other words, when you're about to lose friction.
I think I can answer that question. So in neither of the real events, we didn't have this problem. Because basically the car's potential of cornering were more than what we achieved, I think, at the track. Because so basically in Vegas, we went full throttle at the corners, and we still kept the car on its inside the friction circle as far as our computation goes. But in simulation environment, especially in ANSYS simulation, we were experimenting a lot together with the simulation team about what would happen if the tires to the asphalt had less friction. Let's also simulate that also in preparation to the real event, let's say. And what we saw was that there's a way to detect this. If I want to give more details, so the vehicle has a side slip angle and during the corners to create some slip angle on the tires as well. And if you can actually detect, if you can estimate the side slip angle, usually side slip angle measurement is difficult on the real cars, so you need a dedicated optical sensor. to measure the side slip, but instead with the other sensors you have, for example, GPS and IMU, you can estimate the side slip. So artificially create the measurement of the side slip angle. And after that, if you have that knowledge of the vehicle side slip, and you also have your lateral acceleration, you can combine these two metrics and create the plot where you actually see how close you are to the friction limit of the tires.
Yeah, that makes sense.
I hope it makes sense to you guys.
It does. Actually, I have a question. Oh, go ahead. Sorry, Filippo.
Yeah, no. I just wanted to add that what happened here, and actually, I think for probably 90%, if not 100% of the spin that you guys saw during the race. So also for this one, I mean, it's their car, not our car. So I'm not 100% sure about this, but based on the discussions that we had with them after the race, this was more of a planning issue. So the point is, if you were doing everything properly, the car was, as Mustafa was saying, we were operating, let's say, quite far from the friction limit.
Yeah.
But of course, if you do the wrong maneuver at the wrong moment, you are, let's say, putting the car in a place where you don't want it to be. So what happened here, apparently, according to them, was that there was an issue, a combined issue with the perception, which produced, let's say, a ghost detection. And so they tried to do an avoidance maneuver at the wrong spot and at the wrong moments, and that's why they lost the car.
Yeah. I have a question for Mustafa. Did you have something to add?
Oh yeah, I just read the next question of Rainer about the paper on that subject. I'm thinking of it, and if I find something, I'll definitely send you.
Okay, good. We'll post that to the chat here. I have a question actually for Maxime. Maxime, you've now heard about their simulation. Could you compare their simulation with our simulation? What do we do differently? What do we do the same?
Well, it's totally two different simulators. I mean, their simulator seems to be really physics accurate. I mean, more physics accurate than ours. And yeah, generally, it seems that our simulator is really an approximation of the real life, and a really rough approximation, in fact. And there seems to be like quite close to what they have in real life, and we are operating at totally different speeds. Here we are talking about hundreds of meters per second, maybe not 100 of meters per second, but
more like
close to
yeah, close to it. So yeah, that's totally different structure. Is VRX developed on? No, it's not developed on Unity, right? It's
no, they have their own physics
definitely.
engine.
So let me add a little bit to this, Chris. So this was during the initial or the first race, and then, for example, the University of Hawaii UCSD team, it's actually closer now to a simulation than you think, Maxine. So we're back to using the unit engine behind it, just like the gaming engine, right? And then, of course, the whole dynamic of the car is different. But we are, Chris, we're back to using exactly the same simulation they're going to see here in terms of the gaming engine, right? But if you don't have the dynamic of the cars there, then it's different. So the models of the car, it's completely different, of course, right? We basically simulate a 1/10 scale. And then this hardware on the loop, funny enough, that's exactly what we're going to be seeing all the UCSD students running today, unless they have the a Docker container, and I know they don't. The code actually run on their machine, simulating the computer that will be on the loop, right? So that's several similarities. And Maxine, some of the teams are actually going through using Unit now as the gaming engine behind all the simulation, the physics around it.
One of the big differences is that we don't provide localization data, so you don't have perfect information about where you are on the track. So we don't.
We provide it, but for the moment, it's really, I mean, not hidden, but
the code doesn't
really have
use
to.
Yeah,
yeah, that's the thing. For the moment, we don't use it, but that's potentially way of improving our models, for example.
Exactly. So just for those of you who are new to this, we actually have two different kind of real world races. We have indoor races, which are entirely based on cameras and LiDAR. And then we have outdoor races, which also include GPS, which would start to tell you where you are in the world. The donkey car framework, which most people use here, is, although it can use GPS, almost everybody here is just using cameras, and some of them are using LiDAR. So there is, in the standard framework, there is no localization. It's all based on perception, and that's a difference probably between these two. You don't have perfect information about other cars. You don't have perfect information about where you are on the track. You just need to figure it out with what the camera or the synthetic camera is generating.
Plus, like a big difference, Chris. Those students are 2 weeks into this simulation, deep learning versus PhD is working this for a while, writing all the background information. So in the sense, we can feed a lot of students to this program. I mean, you have 2 students right now that's part of the team and another 6 joining because they started here, Chris. And you get that little bug, people like that, they won't go deeper, right? I think this do-yourself-RoboCar community is a great way actually to feed people, especially if you have something similar on a college that feed into this program.
Yeah.
So
and
most of the races you're going to see here, they don't have more than 2 weeks doing this.
And it's worth noting that we are starting to ramp up our outdoor program, which has GPS, and that's much more analogous to what IAC is. The donkey car framework does support GPS and other forms of localization. We just have not been using it very much, and so we're going to be spending more time on that. So it maps neatly. I know we're running out of time. I wanted to ask, Dimitri asks, what is the FPS on this simulator?
I can again answer that question. Thank you for the question. In this Simulink simulator that we created ourselves, we use 500 Hertz for the physics engine. This kind of high number, let's say, was basically because of the fact that we also simulate the tire rotation dynamics. And this physics has particularly high natural frequency, so you have to up the frequency to be reliable with your integrators. But in terms of communication between the speed goat and with the actual car code, around 100 Hertz of communication was enough to have the car controllable with our control algorithms.
Great. I had one last question for you. I know there were a lot of challenges with the software stack, with the hardware that was provided to you. Can you briefly say, maybe what some of the top challenges were? You mentioned, I think they used the AutoWare stack. How did that go? When you integrated with the cars themselves, I know GPS was an issue. We already talked about some of the controllers having power issues. Maybe just 2 or 3 things you could mention that were difficult.
Yeah, it's funny that you said it's a quick question, like I could stay here and talk for 2 hours. This competition was 70% solving issues. So yeah, what we had here, this is let's say a rough scheme of what we got with the car. The only part that we were allowed to change was this AD-Link. So the code that was going into this AD-Link computer, which is embedded PC kind of computer running Ubuntu and ROS. Okay, so at the beginning there was this let's say base software kind of thing that was AutoWare based, which was, let's say, partially actually at a huge percentage was developed by the teams, let's say in a collaborative way, and which it was kind of AutoWare based, but a lot of the stuff, of the important stuff, was actually developed by the teams. And after the first, that's what we used to run the first few runs of the car ever, like in June or something. Then July. June, July, yes. Then in August, pretty much all the teams transitioned from AutoWare to their own, let's say, their own developed software. And the only thing that stayed, let's say, that we kept using was, let's say, all the drivers related to the sensors. And the biggest issues were related, at the beginning, they were with the GPS. We were having a little bit of issues because the GPS, like the unit, is it's a very good one. Like we have two units, two GPS units. Each of them has two antennas with RTK correction. So it provides a very precise localization and also a measure of the heading, which is very precise when it works. It also has a embedded IMU. And the problem is that it's a product, actually, most of the problems were related to the fact that this is a product which was designed for automotive, and it's probably great for automotive. The problem is that when you, let's say, go above 100 miles per hour and you start to go faster and faster on a car, which is a race car, so it has a lot more vibrations and stuff. Most of the internal, let's say, computation algorithms were kind of starting to behave in a weird way. So we had a few issues with that in the end we were able to solve. Actually, we had a good, let's say, discussion with Novatel, a good and productive discussion with these guys. We were having issues with the radars. Actually, in the end, for example, one of the radars we were never able to use. There was supposed to be a rear radar, which we were not able to use because it was designed to be mounted forward. And so funnily enough, they put it in the car mounted backward, and that was not working. We were having issues with the cameras because of the flow, let's say, of the, because, you know, the data, how do you say, the bandwidth required is pretty high. So, I mean, it was complex to handle. Let me see, the LiDAR never actually gave us problem. This LiDAR is it's kind of amazing. It has an incredible resolution, which you can actually change real time. Oh, a funny thing, for example, we use the fact that you can change the field of view of this LiDAR. You can change it dynamically while you go. And we actually exploited this in the Las Vegas race, because in Las Vegas, like, the banking is very high, as you can see here. So this was a huge issue for the field of view. And we exploited the fact that you can change the field of view dynamically to actually have a bigger range in the turns. So we were basically pointing the field of view a little higher. And then we had a whole lot of issues with the, let's say, integration of the whole system. Like, you can see that you have our computer is here, the orange one, then you have another ECU, and then you have another ECU before actually getting to the steering, which was I would say, it was introducing delays and stuff. So yeah, again, I could talk about this for hours and hours.
How about like vibration, PCI buses and things like that?
Yeah, vibrations. Yeah, vibrations were a big issue in general. Like, again, as I told you, for the GPS and IMUs, and also for all the other components. Like, every component here, as I think it's always in a racing environment, in real racing, every component is stressed like a lot. It's pushed to its limit. So yeah, most of the issues were related to the fact that we are pushing everything to the limit.
Excellent. Well, this is fascinating. If people wanted to learn more about Polymove and your follow your team, how should they do that?
Oh yeah, I forgot to put any links or stuff. We will share it with you guys later. My boss is gonna kill me. So we have a web. Yeah, okay, you can share them in the chat or somewhere. We have a LinkedIn page, we have a website, and we have an Instagram page. And as I told you, we are planning
no Twitter handle, guys. No Twitter handle.
Oh no, we don't have that.
Oh no, we don't.
We don't do that. But yeah, as I told you, we have plans to grow in the future. So if we have any updated information, in terms of where you guys can reach us, we will share it through our social channels. So again, LinkedIn and Instagram are probably the best places to find us.
Very good.
May I ask one last quick question? Are there any more races that are scheduled?
Not. I don't know about. I don't know how much of this I can share. I don't think they're gonna complain, but there is. No, Musti, you want?
We're planning for next year, let's say.
Okay.
Actually,
let's
keep
it this way, Alex. There is some word on the street, and the word on the street cannot get out yet, so we'll see how it goes.
All right, it's not dead. Good.
Okay.
Yeah, no, it's not. Actually, it's probably earlier than next year, but we'll see.
Okay, well, that's exciting. Filippo, Mustafa, thank you so much for your time today. You're certainly welcome to stay with us as we go into the races. But that was inspirational, and someday I think these students if they get their, if Jack trains them right, they can be part of teams like this in the future.
Again, it's just that 20-page exam, Chris. It's just physics, dynamics, C++, and then people can join us.
Very
Oh,
good.
it's okay.
We are trying to push the competition, but we are gonna need people eventually. So they are gonna be welcomed to join the team.
Yes.
So hey, do they have to speak Italian to join then, or not? English
Oh,
is
ask
good.
Musti. Musti, do they
No,
have to
I don't speak Italian. No, I'm not Italian, but they still accepted me. So.
All right. Well,
thanks, guys, for having us.
Thank you
very
so much. All right, that was fantastic, Alex. Thank you so much for setting that up. And now we have a lot of races today. We're going to try to get through this as quickly as possible. But we have 30 racers, which is close to a record. We are going to be running them 2 at a time, and there is a rota. So we'll be starting with Roger Kim and Caitlin Lee. What's going to happen is we will on the Twitch, you'll be right now, you can see the rota, but we'll be switching to the simulator view. Again, reminder, everybody, if you are on the Twitch, turn your volume down so we don't get a crosstalk between that and the Zoom. So right now you're looking at the simulator, and we're waiting for the first 2 racers. That's again Roger and Caitlin, to join the server. And when they do, their cars will immediately pop up. When their cars have popped up, we now have both of them. What's going to happen is I'm going to say, not yet, but I'm going to say, on your mark, get set, go. At that point, they will switch into auto mode. Their cars will go. Their times only start when they cross the start line. So even if you might see one starting before the other, don't worry about it. It's all based on automatically timed from the start line. We will run 3 laps, although only the fastest lap is the one that's going to ultimately determine their ranking. When they're done, again, we remind them to log off the server so that the next will come in. So with all that, racers, are you ready? Yes, Roger, Caitlin, are you ready?
Yeah.
Very good. Okay, on your mark, get set, go. So the 2 cars head off. We'll narrate a little bit. So that collision is common. However, excitingly, Roger was able to recover from that. So we'll let Roger get his time. Now, we're going to have a policy issue that we talk about as we go along. We're giving the racers just 1 chance to get a time. However, in this case, it looks like maybe Roger's going to hit the wall. We may get 0 times on this. If a racer has been disqualified for reasons that are not really their own fault, we might give them another chance. So Jack, I'm going to let you be the judge here. Do you think that Caitlin deserves another chance?
Yes, I think so. And then I think also was pretty nice because it didn't disconnect and connect back on the server. So do not connect again until Chris tells you so. All right, everybody. If not, you can really mess up. If you crash, do not disconnect. Leave it as is, and then we'll make a judgment.
Okay. Speaking of judgment, Roger managed to get out of that collision very well, but then his car crashed on its own. So I would argue, and Roger, forgive us, we're talking about you, but you're just an example of what we'll see many more times. So I would say that Roger's car does not deserve a second chance because it failed on its own. In other words, it was a code thing, not a circumstance thing. Jack, what do you think?
I agree. Let's move on.
Okay, so Caitlin, we're going to give you another shot. We're going to actually move. What we could do is we could just, since Caitlin's ready, we could just have her run with Moises right now. What do you think? Okay, so Roger, by the way, did get points on the board. He did complete 2 laps. 22.01 is his best time, so that's a good time. So why don't we have Caitlin? Why don't you stay with us? Moises, you come in, and we'll have you 2 race against each other. So we're now waiting for Caitlin and Moises to join. Very good. All right. Racers, on your mark, get set, go. Okay, once again, the two cars start close to the same time. This time we do not have a collision, which is fantastic. So what you're seeing is the cars are in fact navigating, which is great. You can see differences in tuning. Some are more aggressive. This had to do probably with the training that they use. Caitlin, can you tell us a little bit about your training?
Yeah, so basically all my training was that I just practiced driving this myself manually with a controller, and that was it.
Looks like you did a good job. You're taking not only a pretty smooth line, but it's a racing line. I would call it an efficient line. Moises, it looks like you wiped out. What happened?
Not sufficient training.
Fair enough. Fair enough. Caitlin, about how many laps did you do?
Well, I've made quite a bit of models, but for this model specifically, I think it was about 30 to 40 laps.
It's really performing well. Every time I say that, of course, I immediately spook it and it crashes. But it's quite aggressive the way you're driving. I'm looking at your time right now, but it looks like you are the leader at the moment with a 19.3. So that makes you the fastest time on the track so far. Maxime, we had time for. We had a time for Roger before.
So what was it?
You had a time for Roger before and it got erased.
Sorry. Yeah, sure. My bad. I thought we would just erase. Okay.
So I have them. Yeah. So I think Roger was it was 20.03 or something like that.
Yeah, I have them.
Yeah. Okay. Very good. All right. So Caitlin has had her 3. So Caitlin, Moises, you can now disconnect. The current leader is Caitlin with 19.3 as the fastest 1 lap time. Our next is going to be Aksharan and Jacob. So Aksharan and Jacob. Other racers, you can see you have the link. You can see when you're up next. So be ready. After this is going to be Andrew and Guy or Guy, I think. Okay, so we have Aksharan and Jacob. Racers, on your mark, get set, go. Now you'll note that the cars sometimes have different colors. That's arbitrary. They can choose any color they want. You can actually choose any body you want. They seem to be mostly using the stock body. It doesn't actually change the way the cars perform. It's just cosmetic. Aksharan, it looks like you're going quite well. Can you tell us something about your training?
Yeah, I actually didn't do too much training, so this is only like 9 laps. So I was like going pretty slow, but it does like drive pretty smoothly. But there's like one turn where it kind of like hits the wall and kind of goes out. But yeah.
Yeah, and Jacob, how about you?
Yeah, I just try to drive my car, as many different ways as possible. I guess like I tried to take the turns differently in different ways, so that would have different experiences.
And what do you think happened? You're hung up on the wall now.
Oh, I'm gonna blame latency.
You're not running the Docker container, I assume.
Yeah, I'm not.
Okay,
I think so.
Fair enough. We'll take latency as the likely excuse. All right. Aksharan is, I think, just finishing his 3rd lap, if I'm not mistaken, or maybe has just done.
That's right.
Very good. Caitlin is still in the lead. And did Jacob get a lap or no?
He didn't, unfortunately.
Okay. All right. So that'll be a DNF. Although he was wiped out by latency, not another car. Because of that, he unfortunately will not get another chance, but that's okay. There's always next race. By the way, this simulator can be run by anybody at any time. You can run it locally on your own computer. You can run it on the server. So this is just an opportunity for us all to get together and run at the same time. But if you want to run this yourself, just go to DIY-RoboCars. Sorry, donkeycar.com. I believe donkeycar.com to the docs, and you'll see exactly how to set up a simulator yourself. Okay, next up is going to be Andrew and Guy. So Jacob and Aksharan, if you could log off. Maxime, how's the simulator running? It looks pretty good from here.
Looks good with 2 cars, so hopefully it will work all the way.
Yeah, it's very smooth. Okay, racers, on your mark, get set, go. All right, they're both racers are off. This just the fact that these like most cars are actually working, and it's running, and that we don't have them pipeline. But this has just been a lot of work from Maxime and Dmitry and Jack to get this running as smoothly as it is running. To get this many cars going and the whole race moving as quickly as possible, you guys are fantastic, and you should be proud of what you've done so far. All right, Andrew looks like he's doing aggressive. A guy wiped out on the wall, which happens. Andrew is taking an aggressive approach. I can see a racing line at work, and I'm expecting some good times here. Did Guy get a lap or no?
He didn't.
Did not. Okay, so that's a DNF. Again, if you wipe out on your own, unfortunately, that's it for you today. If you get wiped out by somebody else, we'll make a judgment call. Andrew's first lap was his second lap at 21:37. I think puts him in 3rd place right now, but that's a really good performance. Andrew, say something about your training.
Hey there. I found that getting the training data as consistent as possible led to better results for myself. So I did a lot of training on the laps before I even went to the record mode. So that way I had good data. And surprisingly, this was my smallest data set.
Interesting. Well, it looks great. I think you're in 3rd place right now, which so far would put you into the ladder, but we've got a lot more racers to go. All right, next racers up. So if Andrew and Guy, if you could log off, next racers up are going to be Bishavjet and Hugh Liu. Bishavjet. I'm sorry.
I should be Bishavjet.
I did actually type it wrong. Yes, Bishwajit. Okay, so you two are up.
Yeah.
Waiting for that.
So far, so good, Chris.
Very good. All right, racers, on your mark, get set, go. Okay, Bishwajit is off. Hugh is waiting to go into auto mode. Oh, and off the track. That's quite a crash. So Bishwajit took an aggressive line, and unfortunately it did not work out for him. Hugh, what's going on? Is it having a trouble switching into auto mode?
I think so.
Yeah, the button I'm using isn't really working right now. Let me try reconnecting the controller.
While he's doing that, I'll remind everybody how this broadly works. So if it is running locally, they typically will have a controller, and they'll initiate it with a button on the controller, just as you would do in the real world. There's other ways to do it. You can do it with a web interface, but in this case, they actually have a video game controller in their hand, and that's how you switch. That's one way to switch modes. While he's reconnecting, we've heard a lot about training, and most of the ones that are using the donkey car framework are okay. Hugh looks like he's back in. Hugh, when you're ready, just switch into auto mode. Let's see if it works. There you go. Okay, he is off. So while he's doing that, I should say a little bit about how training works here. The donkey car framework uses a end-to-end neural network. The particular kind of training here is what's called, oh no, wiped out, and also off the, my goodness, dramatic. Okay, so both of them are a DNF, I'm afraid, because of their own crash. So if you two could log off. Next up is going to be David and Quinn, David Chow and Quinn. So if you two could log in. While they're logging in, the form of training here is called behavioral cloning. And the way it works is that the vehicles can drive in manual mode, by which you use that controller to like literally drive the car around, either a physical car or the car in the simulator, and you just drive it around the track as you would like in a video game. The car, the code is then recording the images that the car sees, be real camera images in the real world or simulated images in a simulator, and then also records the inputs that you gave it when it saw those those images. And so it tries to drive like you. It tries to learn from your driving style. You do enough of these, and then we go into auto mode. It's basically AIU. It's trying to do its best to drive the way you would, but it's completely autonomous.
And then what's the technical term for that, Chris? Is it human behavior cloning?
It's called behavioral cloning. There's probably another way. Jack, what do you call it?
We call the human behavior clone just because you basically cloning the human behavior on that.
Yeah, there are other ways to do training. There's simple supervision, where other frameworks like the Jet Racer framework, where you just sort of click on the track where you think it should go, and it goes there. There is reinforcement learning, where you could just tell the car, and you can use the simulator for this as well. You tell the car, you give it sort of rewards and punishments. You can say, give it a reward for staying on the track and a punishment for getting off the track, and let it figure it out on its own. That works well in simulation. It's kind of hard sometimes to take it to the real world, where the simulation is not a perfect representation. So these are all various techniques, and we'll get into that later. But first, we have two racers, David and Quinn. On your mark, get set, go. All right, they're both off. This could be a dramatic first corner. Wow, David passes on the inside. Very impressive. Oh, this is a real race. All right, both cars are doing well. Both are taking a line. Hey, David, when you passed, did you train with other vehicles? Is there any actual car avoidance going on, or was that just luck?
Oh, that's pure luck. I didn't do anything about, yeah.
Fair enough. Maxime, while they're going, could you say a little bit about how you could train with another car on the track?
So either you have an existing model that you could use as a dummy car in front of you, for example. Either you could use a new feature of the simulator, which is called a pace car. It's basically a car that stays in the middle of the road and it drives itself. So basically you could train on overtaking this car. But I think for the moment, the best solution would be to spin up multiple cars and multiple models, and drive as you would for the training.
That's excellent. So in other words, the first model is obviously just against the track, but the subsequent models you're training against the track and other cars, and you see enough of those, and presumably it should work in the real world. Okay, both these racers are doing very well. We're starting to see some times. It looks like David at 1936 is just behind Caitlin, is now in second place, and Quinn's numbers are coming up, also solid. His second lap time is looks like his best time so far is 24. So right now in our rankings, Caitlin is still in first place. We now have David in second place. And if I'm not mistaken, I think we have Andrew. I think we have Andrew in third place. I'll work it out later. Excellent running, both of you. Okay, next up is going to be Antonin and Rainer. These are both veterans. Rainer is showing up here as Parking Lot Nerds, and these are veterans with good experience. Rainer has won in the past, so we're expecting great things from him. As you can see, Antonin has got a cool body that he's chosen here. It won't make any difference on the aerodynamics.
He has some kind of RL in front of his name, Chris.
Antonin. Okay. Well, let's get them started, and then Antonin, while the car's running, can tell us what the RL means. Racers, on your mark, get set, go. All right, they are off. Antonin, what does RL mean?
So RL stands for reinforcement learning, because I'm actually a bad driver, so I did not do any racing with this car. The car learned by itself. So it could learn to race in 22 seconds in 2 hours, 20, 21, 20 in 5 hours. And actually here you see a model with 10 hours of training. And I'm actually using new features from Maxim simulator, which is running the simulator faster than real time and which allow training also much faster.
Explain to us a little bit of what you mean 2 hours. 2 hours where? Where do you let the robot training? Where did those 2 hours come from?
2 hours on a computer. So it's 2 hours of real-time training. I just let the robot train itself, and basically I don't even optimize for the lap time. I'm optimizing for the speed. So I'm optimizing car speed and smoothness. So to drive as smooth as possible and as fast as possible, while obviously avoiding crashes. And this is being able to drive faster than 90 seconds normally.
It's incredible. You're at 18.89. You're in first place right now. That is the most beautiful race I have seen.
Thanks.
It works. Look how well that is running.
So actually, that's not the fastest one, but it's the most stable one.
and no human in the loop, Chris. It's like the machine was running by itself.
So the only thing so obviously when you see this, you say, well, everyone should be doing reinforcement learning. This is such a superior method. My only point would be that it might not work as well in the real world. Whereas Rainer, you're using a classic donkey, behavioral cloning approach, right?
Yes, and I trained with other cars and tried to recover from crashes. So I hope I do not need that feature, but right. I trained at least a few crashes and recovered from them.
So let's get a debate. I would predict that although it looks like Antonin is going to win this race, looks like he has won that race, I would predict that Rainer's model would translate to the real world better. What do you guys think?
So actually my own research is not about transferring to the real world, but learning directly in the real world. So you don't have that transfer problem. Actually, so it would take much longer than behavior cloning to get to the same performance, but the main interest of RL is that you can get better than the human. With behavior cloning, you can only get as good as a human. And here with RL, the nice thing is if you let it train longer, then also you will get better.
Yeah, that's right. When you say reinforcement learning in the real world, obviously in the simulator, you can automate the process. It just automatically restarts. In the real world, how do you automate reinforcement learning?
You don't automate. You need a driver, a safety driver to recover from time to time. Exactly. Or you need some basic strategy to recover or prevent crashes. That's also a big issue.
Yeah, so obviously hours are free in simulation, but are not free in the real world. So you have a constraint.
Plus, you can crash and break things too, Chris. So depending
that's
how
right.
the crash is going to be.
That's right.
Now, these two races has something different from the others so far, Chris. They are running the containers, and then Rainer, how about explain why would someone need to run a container on the server? Where are you located? What are your average latency?
Well, I'm located in Germany and having about 200 milliseconds of latency. So the Docker container enables us to have the car really get the feedback of the camera signal and the driving signals of steering and throttle back to the simulator without these latency issues we had in the past. So that's really, it's great to have that. So thank you for making that possible.
Again, that's a really good point. Thank you again, team, for making it so smooth as well. Antonin, I have one last question for you. In reinforcement learning, can you bring in other vehicles? Can you teach it to avoid other vehicles as well as just follow the track?
Yeah, that could be possible. In fact, I did not with that car, but afterward I also tried some training with running dummy cars, so also the model that are not training and running the other car, trying to learn to avoid. Didn't get better results yet, but yeah, it's totally possible.
Great. All right, so we now have a new leader. Antonin is now in first place. Interestingly, Rainer did fantastically, but Caitlin's 19.3 is still good for second place. David's 19.36 is good for third place, and Rainer, you are in fourth place, if I'm not mistaken. Still in the ladder, but it's starting to get competitive. All right, next up is going to be Cam and Juan. Cam and Juan, you are up. And after that, it's going to be Giancarlo and Dimitri. Interesting. We've only had to give one person a restart because of a crash. So that's it's going well. All right, racers, on your mark, get set, go. When you see the UCSD prefix, that means they're all students of Jack's at University of California, San Diego. And they are both off.
Sorry, my Wi-Fi is awful right now, so I'm having trouble getting mine going.
You are going. You just crashed.
Oh, okay. Yeah, I can't see that.
Yeah, if you open up the Twitch, you can see that you are stuck on a wall at the moment.
Well, yeah, but I can't see the Twitch because my Wi-Fi is so bad.
Oh my goodness. Okay. Jack, what do you think? Should we? I mean, his Wi-Fi is not going to get better if we give him another.
Yeah,
another
so
go.
I think we keep moving. In the end, if we have enough time, there was somebody asking to see if we could get another round. We'll go from there, Chris.
Okay. So Cam, if you can find better Wi-Fi, we'll give you another shot. If not, we should assume that the same would happen. So let us know if you can get better Wi-Fi. Juan is doing very well and is now finished. Juan's best time was 25:18. Okay, next up is going to be Dimitri versus Kirill. This is not the first time we've had two Russian names against each other, maybe even these two Russian names against each other. So Dimitri and Kirill, you are up. By the way, I have no idea whether they're actually Russian. I'm just guessing.
Yes, I'm Russian.
Привет.
Yeah, very good. Okay, well, because you're Russians, we expect you to be geniuses, and we're expecting good times here. On your mark, get set, go. Okay, both are off. Dimitri has, as you know, he's part of the team that's working on the simulator, and so you imagine he's doing well, and he is indeed. Look at that; that's a beautiful line. Kirill's also doing a very aggressive line, beautiful racing line, taking the inside. Kirill, what's your technique? What's your training technique?
Firstly, I have trained my brain for several laps, and then just doing behavior cloning.
Yeah, this is a really good looking race. And Dimitri, how about you?
The same thing, the simplest model with behavior cloning, but I trained, I collected the data for 60,000 records. So yeah, quite a lot of data.
We
but
see
yeah,
go ahead, yes, sorry.
But first of all, I was needed to figure out the best line to follow. That was the challenge on this track.
We have a potential passing opportunity here. Kirill, do you think you're going to be able to pass Dimitri?
It's possible.
This is very exciting. So close.
Those are two other racers using the container, Chris, so it seems to be working very well.
Very well. Look at this. Oh, this is so close. Oh, I want to see it. I want it to pass. They've got, unfortunately, they finished the race. Should we let them run just a little bit longer to see what they'll pass? Let's let it go a little bit longer.
Sure. In the meantime, the other two folks just get ready. You can see your name on the list.
Oh, I want to see Kirill pass him. Oh my goodness. Kirill, do you think that it's trying to avoid the other car and that's why it's not passing? Oh, they're so close.
I don't know, really.
Oh my goodness. Did you pass? Oh, they're fighting. Dimitri's not letting him pass. Oh my goodness. This is crazy. This is like the most exciting race we've had.
Funny, nowadays I have to keep my mic on mute because I can see the future a few seconds ahead of you guys. I don't want to spoil the fun.
Oh my goodness. I'm just watching the Twitch and it is so close. I thought Kirill had him and then Dimitri fought him off. They were locked. It's right on his tail. I'm not sure the physics actually allows for drafting. and they crash. Oh my goodness. And Kirill unlocks and releases. Dmitry wipes out, going in the wrong direction. Whew. Kirill, you did it.
Nice race.
That was super exciting. Great race.
It was very fun.
Oh my goodness. And fantastic times too. Kirill, you've got an 18.994, which I think puts you in first place. I could be wrong about that. Second place. Whew, oh my goodness. I need to catch my breath after that one. Okay, next up is going to be Yun Chao and Sarp.
Sorry to interrupt. I was skipped over, I think.
Oh, I'm sorry. What was that one? Juan Carlo? Did I?
Yeah,
Sorry.
Giancarlo.
Oh, John. Sorry, Giancarlo. I forgive me. Did you? My bad.
I have not raced yet.
You have not raced. Okay, Giancarlo. It's going to be you versus Yun Chao.
All right. Cool.
Sorry about that. I was so intent on getting the Dmitry and Kirill to go against each other.
You have to disconnect, please, so that Giancarlo can come in.
Yeah, sorry. So we're going to bring you up next. So this is going to be Giancarlo versus Yun Chao. Okay, very good. Racers, on your mark, get set, go. All right, both heading off at the same time. Fortunately, one's a little faster than the other. So, and wipe out. All right, that was a self wipe out. So, but got back on track, amazingly. So Giancarlo is taking an aggressive approach, but so far it's working out for him. Yun Chao is taking a more conservative approach, but also staying on track very well. So it looks like since Giancarlo's had trouble at the first turn, he may have trouble again when he hits it in the second lap, but we'll see. He recovered last time. We'll see if he can recover again. All right, Giancarlo's first lap was a 28-second. Decent time. That was actually after getting hung up. So if he doesn't get hung up, and he passes and wipes out. Oh my goodness, the pass smacked Yun Chao, but because Yun Chao did have a time, we're going to leave that. He was an unobstructed first time. And Giancarlo, what do you think? Maxime's giving me a DNF-ish.
Yeah, I mean, it wasn't perfect on the start, so I don't know.
Yeah, it looks to me, Giancarlo, what's your best time in training?
In training, probably around like 20 seconds.
Oh, okay. Actually, we got you at a 20.5. So you've got a time on a good time. So we're gonna keep that time and move on. Okay, next up is going to be Sarp and Hussein. We only have about 10 more racers to go. So we're actually moving pretty well through this group. Sarp and Hussein are both in. Racers, on your mark, get set, go. Okay, both head off at exactly the same moment. And Sarp's getting up a little faster, so there will have no collision at the first turn. Hussein's taking a good conservative line. Sarp, while you're in the lead, what's your technique?
Honestly, just drive and kind of hope for the best.
Are you a good video game player?
I'm okay with like first-person shooters. I suck at racing games, so no. Also, I had to like slow it down for the server because consistently, even though on my local machine, it was running no problem at max throttle, on the server consistently, I crashed. So I had to slow it down a bit.
Interesting. Okay, but still, you adapted, which is great. Hussein, you're obviously taking a conservative approach to make sure you don't crash, and you're not crashing. What was your technique?
Honestly, after doing it so much and just keep crashing because of some issues with the controls, I just had to slow it down and try not to crash doing like 20-30 laps. And that's working out for me, honestly. That's a win. Even though if I get a low time, at least I didn't crash, which is completely fine.
It looks very solid. You're in a interesting.
Now I did.
You did, although you could argue that maybe the fact there was a car in front of you threw you off. So, you know,
could be.
Yeah, it was going very well before that. All right, so both of them got times on the board. Sarp, your best time was a 22.89, which is solid. You might get. I'm not going to say whether people are getting into the ladder yet because I need to do the math. All right, next up is going to be Tara versus Hirohaku. Tara, I think, is a newcomer. I could be wrong, and Hirohaku is a returning racer. So Tara and Hirohaku. Hirohaku is, I believe, one of our Japanese stars. Okay. Racers, on your mark, get set, go. Hirohaku is using a classic donkey chassis. Heads off, very solid. You can see that that's experience. Tara, any trouble getting into auto? Oh, there you go. You're off. Never mind. Okay, so Tara's running pretty smoothly. Again, the time starts when you cross the finish line, so there's no penalty for being late off the finish line. Just got past. Hirohaku is zipping around, lapped Tara, but Tara's sort of bouncing off the walls, but so far so good. Hirohaku's first lap is 20.82, which is excellent and reflects all the experience there. Hirohaku, any new training this time?
Well,
Turn off your Twitch audio.
no, I try to volume up my data.
Yeah.
Number of data. So I use 70,000 of data to train.
Wow.
And yeah, and when I get some data and keep same lane to run.
That's fantastic.
Mm-hmm.
Look at that. That is just, I mean, you know, everybody who's involved should feel good about that. That is, I believe, the donkey framework. It's just good training, good tuning, lots of experience, just a really smart strategy, but shows how powerful behavioral cloning can be. With 19.11, I believe that Hirohaku is in second place no, that's right, in third place after Antonin and Kirill, but really excellent times. All right, bravo, both of you. Next up is going to be Parker versus Kuro. Okay, Parker is up, waiting for Kuro. After that's going to be Chen and Huang. Okay, racers, on your mark, get set, go. Parker heads off first. Kuro is off as well. Oh no, Parker wipes out at the first turn and is off the track. Kuro also hits the oh my goodness, that was ugly. And now Kuro's going the wrong way. I say we restart this race. What do you guys think?
Yeah, give them a chance. They can come back really quick.
Oh, okay, guys, disconnect, reconnect. We're going to have you run again. Parker and Kuro are going to go again. Kuro, disconnect, reconnect. Okay, now Parker, you crashed on your own, so that might happen again, but Kuro was wiped out by you, so maybe he'll have a better run this time. Kuro is now reconnecting. All right, racers, on your mark, get set, go. Now, Parker, I think you're still, I think you were in this lane last time as well. So I'm expecting the same results, but who knows? Could be different. Oh no, Koro hits the wall and appears to be stuck. Parker, you're doing pretty well so far. Koro's vehicle is backing up and trying to restart. Might happen. Parker, what do you think?
Looking pretty good. Never hit a wall in all my trials, so a little confused about what happened just now, but excited to see that it's working.
Yeah, you lucked out. We gave you a second chance, and this seems to be working for you. You've got a 20.56, which is a great time. Koro seems pretty locked up at this point. If you don't hit Koro, looks like you're going to get 3 laps. Oh, a 19:15. My goodness, Parker, what's your secret?
I honestly have none.
Video game player.
Are you a video game player? Are you?
I am not.
Just lots of training.
40 laps.
40
just,
laps.
I guess, good enough training.
All right, very good. Okay, it looks like Kuro is the DNF. Did not finish, but that's okay. There will be another time in the future. Next up is going to be Chin and Huang. John Chin and Huang Peng. And after that, we have just 3 more racers. John is in. Huang is in. Racers, on your mark, get set, go. John is off. Huang is off. Okay. Oh no, Huang wipes out on the first turn. John seems to be doing pretty well. John, what's your training technique?
Well, I had to train on keyboards because I don't have a controller, but my strategy is I'll have a time at least in the first round, and then I'll try to up the speed maybe in the next round. So at least I have a time. That's my strategy.
Yeah. Okay. Well, the first part of that strategy looks like it's going to work. It looks like you're going to get a time. Unfortunately, because we have so many racers, you're not going to get a second round this time.
Oh, okay.
But you can come back next time, or just do it again.
Yep.
Okay. Yeah, John, you got a time on that first lap. It looks pretty okay. So it looks like I think I'm going to move on. But I think you get points on the board. So bravo on that. If you could log off, we'll now have Zayu and Shugasin from Japan. Zayu and Sugasin. And then after that, I just have one more racer, Hua. Is there anybody else? Typically, I want to have 2 racers on the track. So assuming that I get Sugasin should be coming in now, assuming these 2 race, I have one slot open. If somebody wants to get one more run, I have an opportunity for them to run against Hua. So think about that. Again? Who was that?
Hugh, I crashed on my race.
Okay, good. Well, so we'll have you go against Hua. All right, racers, on your mark, get set, go. All right, both racers are off, both performing very well so far. Oh no, Sugasin wipes out, but I think recovers and possibly going the wrong direction. I can't tell. I think Sugasin is coming from Japan and maybe dealing with latency issues. Is that correct? Is that latency?
No, running on a container.
It's not in a container?
And what I meant is, no, it's not latency, and it's running on a container.
Oh, it is running in a container, so it's not latency. Okay, so so sorry about that. That was just that happens. But Zayu, you're doing very well. What's your secret?
I just try to run it as smoothly as possible. I just get a little bit experience when I play GTA 5. So
there you go. Yeah, you're a good driver. Okay. It looks like your best time right now is 23.9. It's a good time, and yeah, 23.81 is your best time. Okay, our last one is going to be Ahua versus, and now I'm forgetting who was it who just spoke up, who was going to take this
me.
last. Bring up my Zoom so I can figure out who that was. Sorry, I didn't have my Zoom
Hugh,
up.
it was you.
Hugh, very good. Okay, so I'll write that in. H-I-E. Okay.
I got it, Chris.
Oh, you got it. Very good. Very good. Okay.
Yeah.
Thank you. All right. Okay, Hua and Hugh, you are up, and you are going to be our last race until we go into the ladder. After this race, Maxime and I will take just a minute to make sure we will build the ladder, and then we will switch into the ladder, and that'll probably take us about the ladder should take about 10 minutes, and then we'll be done. Okay, Hugh is up, and we're waiting for Hua. All right, both racers are in. On your mark, get set, go. Hugh is off. Looking very good. Hua, trouble switching into auto mode?
Yeah. I think it's Wi-Fi issue. I'm trying to figure it out.
Okay. Well, he was just going to run ahead, and that's fine. Your time will start when you start. Oh my goodness, Hugh got a 1989. Good on you. And you're not running into Hua, which is excellent. Wow, Hugh, what's your secret? That's fantastic.
I did a lot of training and different models. This one was like the most aggressive one I could get without it crashing.
Well, you just smacked Hua, but it doesn't matter. You got an amazing time there. Hua, do you think you can fix your problems?
Can I join the game again?
Yes, you can disconnect and reconnect. Yes. Hugh, you should disconnect. We'll give Hua one last chance to reconnect and go. Okay, Hua, you're going to run on your own. So on your mark, get set, go. We'll give you a few seconds to see whether you can get this working. There you go. Okay, you're off. Okay, well, oh no, and into the wall. Sorry about that. It happens. Okay, that is the end of the regular racing. Jack, can you entertain everybody for a minute or two while Maxime and I figure out the ladder?
Yeah, very easy, everybody. 5 minutes bio break and come back, and I'm gonna do this really quick so we don't get too much overtime. I think no matter what, that initial conversation with the Polymove was an awesome discussion, so totally worth the time. So 5 minutes or so, come back, bio break, and then we continue.
Jack, are you still there?
I'm here.
How was your experience at CES? Maybe for entertainment value. Can you, I don't know if the guys are still there, Mustafa and Filippo, but maybe you can tell us a little bit, how did things go down at CES internally?
So we have the record of spinning without crashing until this, until the last Saturday that we crashed. And then, believe it or not, most of the spinning actually was hardware, because we never really went above 9 miles per hour. So we're not at the limit of the dynamic of the cars yet. But all the components you saw there are so many safety in place, like you saw the different 3 levels of ECUs. And if any of those lose communication for the next level, they're going to put the brakes on and stop. And then that's good and that's bad, as you can imagine, right? So there are many, many, many opportunities for hardware improvements. The teams went there not to do hardware development, not to do firmware development, but as Polymove was saying, a lot of the time was being done for troubleshooting and helping to have the minimum capability. In our case in particular, we joined the game a little bit later, so we had 2 students, I'm talking about 2, literally 2 undergrad students joined the University of Hawaii that have another 2 or 3 in sometime June when there was a vacation at UCSD. So we started like way months behind of all disorders on the top of course, they being PhD, doing controls and things like that. So we really underdog on this, even though I'm happy. And then, so this time we went to Las Vegas. Again, that same 2 students, one of them now is a graduate student. And then they went sometime before Christmas. And then several other students that were already preparing for the next wave of competition. So they went about Christmas time, after Christmas. So we just have a few weeks to work on it. So for all the purpose, like just like here, right? Preparation pay off. And if you don't put the time for one is on the other, like the students have to go to school, they're not a PhD and doing the research. They're saying if you go there, it's part of the research. They have to do their classes, right? And on the top of that, coding, and some of them, actually all of them learning from scratch. So in my opinion, it's a lifetime opportunity. I mentioned to everybody that was involved on this, I don't think you want to have a chance to do high visibility projects like this in your life again. Some do, some don't, but it's rarely, right?
Depends, right?
If you go take a look there, we had 9 teams from the first race. This race we have 8 teams, and if you add, we don't have, but let's add 8 people or 10 people to each, it's 80 people around the world doing this, right? So, and if you see the population of the world is billions of people, so it's basically 80 divided by billions, and you see how many people have a chance to do this, right? So slim chance.
Jack, maybe another question is because some
actually,
of the folks...
well, just before Jack, could you switch to the ladder tab on the display?
Yep.
Thank you, Maxime is finished with the ladder. So while you guys continue talking, just we're now ready, and if everyone will look at the ladder tab, you'll see who's up. It's going to be Hugh, David, Hirohaku, Parker, Kirill, Dmitry, Antonin, and Caitlin. Oh my goodness, we have Kirill and Dmitry against each other again. So those racers, you will continue, and you should be ready to run in that order. Sorry, Jack, back to you.
Jack, maybe one question is, I think a question came up. I don't know where I saw it, on Discord or on Twitch somewhere, or actually it wasn't here. If somebody wants to get involved in something like IAC or something like that, how does an organization get itself involved in this?
Yeah, so I'm assuming there'll be, I know they're looking for all the universities to get involved, and I can tell the price tag is $350,000. So whatever institution that want to start from scratch have to come up with $350,000 to actually buy the car. The teams buy those cars, and if you think it's a high price tag, the cost of the car itself, and don't quote me those numbers, I may be off here there, but it's $1 million. And then based after the sponsors, the teams have to come up with, let's say, 350K, and then basically own that car. Right, you can take it home or whatever it is, but in this case, they all stay in on a specific location, but the team has to raise that money. And that's why you can see some universities joining forces, because not everybody can go raise this kind of money. Now, that's for forming a team from scratch, right? So there'll be some registrations. In the beginning, as the Polymove was saying, there was 40 or so teams that have to pass on the simulation. Then after you demonstrate on the simulation and you qualify in the simulation, then basically that enables you to go purchase the car. You can just go walk in and have to demonstrate some of this stuff, and then you're allowed to go purchase the car.
Okay. Let's move on to the last bit of the race, which is going to be the ladder. The way the ladder works is we have the top 8 times based on the fastest 1 lap time. We put 1 versus 8, 2 versus 2 versus 7, and so on. The idea is that, well, you'll see how it goes. But first up is going to be Hugh versus David. So you racers, you will switch back to the simulator, and you should join the simulator, and we're going to see which of you moves on. Jack, if you could, there you go. There's Hugh. Waiting for David. After this is going to be Hirohaku and Parker, Kirill versus Dmitry, and Antonin versus Caitlin. All right, both racers are in. On your mark, get set, go. So in this case, Hugh is favored because he had the fastest time, and David may have changed something. He may have changed his speed, recognizing that he was going to have to kind of bring his best race to this race because he was the slowest of the 8, so he's really going to have to push it. There's no harm in wiping out, but he's actually maintaining a really good distance behind Hugh, but not gaining yet, as far as I can tell. This is a good race. All racers in the ladder are excellent. They didn't get here if they weren't excellent. And the question is, how aggressive are they going to be? Oh, David is looking at a passing situation right on Hugh's tail. Might pass. Oh my goodness. Oh, this is exactly what you want from a ladder. It's really thrilling wheel-to-wheel racing. David is just hovering on the back of Hugh's car, looking for an opportunity on a turn without wiping out. Oh my goodness, it's so close. I don't know what Maxime, are we on the 3rd lap now?
Yeah.
Well done, fellas.
Yeah.
Besides you doing really, really well, anybody from your CSD that got to this round got that free boba drink.
Yeah. Now remember,
Yeah.
it's the best time. So even though so I'm not sure what order they started in, but it may look like one beats the other to the finish line. But we ultimately have to look at the overall time. We'll find out. So it's a little bit of suspense.
So do you want to have the overall time on the 3-lap time?
Yes, I think
Or do you want?
I think it should be the 3-lap time.
Yep. So David was a 59.46, and the other racer was 59.32. So it's Hugh.
Oh
that
my
wins.
goodness.
Yeah, it's really close.
59.46 versus 59.32.
So it's 1/10 of a second.
Wow.
That's really nice.
That's crazy. Okay, so sorry, which was the faster? Was it Hugh was the faster?
Yeah, Hugh was
Okay,
the fastest.
so Hugh moves on. Wow, great first race. Next up is Hirohaku versus Parker. Okay, David, you need to log off, please. Thank you.
Yeah, please everyone log off.
David
would need to exit, please.
If just tell us if you, for some reason, you can't get out, just Ctrl+C on your terminal, should it disconnect?
You said you already logged off.
Okay, let me do it on my end then.
Okay.
You guys can all see the behind the scenes dashboard, which you would see as well if you were to be running the simulator locally. This is the interface you would see. All right, Hirohaku and Parker, you can now log in again. Very good. Racers, on your mark, get set, go. So in this case, they're very evenly matched. Hirohaku was 4th and Parker was 5th. I expect a tight race here. Obviously, they're starting at different times, so it won't look tight initially. Maybe because they started at different times, they won't catch up with each other, although it looks like Hirohaku is...
Sorry. My lap time crashed because obviously Jack disconnected the sim. So maybe we can restart this race.
Okay, yeah, racers, we're going to restart. Could you log off and log on again?
Sorry about that.
Parker, you lucked out right there. I saw you wiped out, so you're lucky that doesn't count. So the reason we're scoring the 3-lap time here rather than the 1 lap is we want to emphasize reliability. Big part of Jack's course curriculum. All right. Maxime, you okay?
Yep.
All right,
Pretty good.
racers, on your mark, get set, go.
Yeah, no, it's good.
Very good. All right, and the racers are closer in their starting times now, so we should have a proper race. Now, last time, Parker was taking an aggressive line and wiped out. Let's see whether how that works out for him right now. Hirohaku is on his tail. I may be closing. It's not very evenly matched. Okay, so Parker, how's it looking for you?
So good so far. No crashes, and it's actually doing the best I think I've ever seen it. So
Yeah, I
I
can
can
see
finish that last lap.
It's an aggressive approach you're using. You're bouncing off walls, but that's okay. That can work. Hirohaku is consistent as always. Very, very smooth. Parker, you're managing to hold your lead. So whatever your tactics were, they worked so far.
And
I did remember that I used to go to actual kart racing, so maybe I got my skills from there. Was able to then transfer that to the video games.
Oh no, Hirohaku is just wiped out and is going the wrong direction.
Anyway, we have the 3 lap times. They both succeeded in making 3 laps.
Oh, okay.
And Parker is going through.
Very good.
With
wow.
About 0.7 seconds ahead.
So close. 0.7. My goodness. Okay, so again, both racers, excellent times. Very close, and Parker goes on. Okay, next up is going to be Kirill versus Dmitry. Now, we've seen this race before. As I recall, according to these numbers, Kirill won last time because he's 3rd overall and Dmitry is 6th overall. But it was extremely close. Maybe they've changed something. Now, Dmitry, because he's very smart, knows that Kirill was faster, so maybe he cranked up his speed a little bit. We'll see. Racers, on your mark, get set, go. Okay, both racers are off. Now, when I say crank up the speed, that's a setting. The racers can choose to, oh my goodness, insane. Dmitry decided to go super aggressive, wiped out, unbelievably.
And he has a special car, like he floats.
Yes, exactly. Kirill managed to avoid the collision. And if Kirill can finish 3 laps, he will move on. Dmitry, oh my, that was a close one. Dmitry, what did you try on this race?
Yeah, I actually changed the model. So I chose the most risky one, but the most fast.
Yeah.
So yeah, I decided that it's impossible to beat Kirill with the model I used because he basically has very good times.
Yeah.
So I changed it, but yeah.
Yeah,
it's still worth it.
It was still worth it. That's a good tactic. You had to do something, right? And that was what you had to do. It might have worked. It didn't. But that's, you're up against a very tough competitor.
Chris, I think this is one of the most competitive races we've seen. That the people that advance, they're really close to each other.
Yeah,
really nice.
They really are.
Yeah.
It looks like Kirill has moved on. So congratulations. This will be our last of the, I guess, of this layer of the ladder, and then we go into the quarterfinals. This is going to be Antonin versus Caitlin. Now, Caitlin, we have a lot of longtime competitors here, but Caitlin, I believe this is your first, isn't it?
Yes, this is my first. I'm a part of Jack's class.
And if I'm also, Jack, how many of these 8 are your students? I can see at least 2, maybe 3?
6, at least 6, I think.
6 of the 8 are his students?
Well.
Yeah. So Hugh, David, and then Parker.
Oh, Caitlin.
And Caitlin, yeah.
Okay, very good. Yeah. Okay, Antonin and Caitlin, you are up. Now, Antonin is favored. He was 2nd overall, and Caitlin was 7th overall. Caitlin, have you changed anything, knowing you're up against this incredible reinforcement learning beast?
Oh, you bet I have. We're gonna see how well it works, though.
I like this attitude. Look at that, Chris. All in.
All right, let's see how it works. Racers, on your mark, get set, go. Okay, they're off. So Caitlin is obviously going to go do something more aggressive. And so far, wow. Oh my goodness. The reinforcement machine, Antonin wipes out, goes the wrong way. Caitlin, all you need to do is finish, but you also have wiped out. Oh no, we have to run this again.
Yeah.
Okay. Let's, racers, log off, log back on. We're going to do this again. I'm surprised, Antonin. Well, once they get started again, I'll find out what happened. But it's very surprising for Antonin to wipe out. He must have done something differently, or Caitlin's car in front of him threw him off.
That's probably the reason.
Yeah.
And there was something weird in the starting for me.
Okay, Caitlin, we're waiting for you to come back in.
Maybe it's time for supper in Europe, and cars are hungry.
All right, Caitlin is back in. Racers, on your mark, get set, go. Now, they're in different lanes this time, so we may get a different result. Oh my goodness, a quick pass, zipping. Oh, they both wiped each other out again. And they're, oh, I think we need to do it one more time. This is too good. I can't let it. I can't let it go.
Let's go. We need somebody to advance.
Racers, last time. We need somebody to move on. Otherwise, I have to make a judgment call, which is not going to be fair. They're so tightly matched, so well matched. They're just like running into each other.
Think about what just Chris said, right? So tightly matched, running each other. What can you do about it?
Ha, good point. On your mark, get set, go. Third time's a charm. Somebody, you've got to get past, get a lap. I will accept a 1 lap time, by the way, in this race. Okay, so Caitlin's aggressive strategy has not paid off. She crashed. If Antonin can finish his lap and there's no other vehicle in the way, then he will move on. We're going to let this go just 1 lap. I think he just finished 1 lap, right?
Yeah.
Okay, Antonin moves on. Caitlin, great race. I totally respect your tactics. You had to do that. It might have worked out. You could see you threw him off by being in front of him, and that could have thrown him off and not you. So smart tactics. You will obviously, we look forward to seeing more of you in the future.
Thank you.
Okay.
That actually was my tactic.
Good. Okay, we are now in the quarterfinals. This is going to be a Hugh versus Parker. Waiting for Hugh and Parker. Parker is in, Hugh is in. Racers, on your mark, get set, go. All right, they're right on each other's tail, and they wipe each other out. And let's restart this one. This is what happens when you have cars so tightly matched. I kind of hope they start at different times, but in this case, they didn't. So let's log off, log back on.
That goes with experience, Chris. You have to try the first time, the second. So wait a minute, let me wait a little bit.
Exactly. When they start at the same time, we get drama, but we also get risk. Okay, racers, on your mark, get set, go. Slightly different start times. Might get the first turn without the... Oh my goodness. Hugh wipes out. Parker, if you can finish this lap, you are in. So Parker, did you crank up your aggressiveness?
I haven't changed anything. I'm just hoping for the best every time.
Yeah. Well, if you didn't change anything, then ideally, okay, you've just finished the lap. So I think technically you are going to move on. Maxime, should we just move him on?
At this point, the SD students should be going, you see, SD. Just like in sports, huh?
All right, Parker moves on. Kirill versus Antonin. This is the fastest human versus the fastest robot. Antonin's reinforcement learning. Kirill, I believe, is actually behavioral cloning. So man versus machine. Kirill is in. Antonin is in. On your mark. Get set. Go. And they're off. Okay. So there's a little bit of spacing in their start. So perhaps they won't hit each other in soon because they're so equally matched in timing. They may never hit each other. Kirill did bounce off the wall, which is going to hurt him on his time, but he's maybe catching up. Again, we're going for, if they both finish 3 laps, we're going for the 3-lap time. So Kirill can make some ground on Antonin. He will have a chance.
So usually Kirill is faster the first lap, but then the racing bot catching up.
Oh. All right. Both looking very smooth. Maxime, what do you think? Who's going to win?
It's close for the moment. But I think for the moment, Antonin is going to win. Yeah, we have the 3-lap times. And,
3-lap times.
And yeah, Antonin gets through with a 0.5 seconds.
Maxine, you have 2 months to bring back the timer. Remember, we have the first lap and the three race laps advance or average. Actually, we have 2 months to code that for the next race.
Yeah.
Okay.
We're going to do a quick debrief after the race, and let's see what we want to do.
Very good. All right, we are now at the end of today's event. This is the big one. This is the finals. Parker versus Antonin for the overall winner. Everyone did really well this time. I think this is, Jack, Maxime, I think this is the best times, the best racing we've ever had, right?
Yeah.
Definitely the most competitive. So it's like people that advanced, they were really close to each other.
And what do you think about 2 versus 4? One of the things about 2 is that we're getting less random crashes. Maybe we should stick with 2.
Yeah, I mean, in our side that worked just because of the performance, even though we're going to optimize this. It's whatever you think it would be quicker, Chris. So you have a good point, right? Sometimes 4, we think it's faster, but there's so many people to come in, disconnect.
Yeah.
So this is going smooth.
And if we're only doing 1 heat and it's 2 at a time, it might be about the same speed as multiple heats with 4. Okay. All right. Before we get started, Parker, you're up against this beast. What do you think?
I'm kind of thinking that the human's going to beat the AI, but we'll see how it goes.
I like your confidence. Antonin, what do you think? Does Parker have a chance?
Depends if he starts first or not.
Okay. So Parker, if you can press the start button faster than Antonin, then you get in front of him, then you throw him off. His reinforcement learning can't handle the car in front of him, and maybe you can beat him.
And be careful of jump starts, because
be careful of jump starts. Exactly.
Yeah.
Okay. Whew. This is it. Racers, on your mark, get set, go. Oh no, Parker did not get a jump start, so you're just going to have to win on pure speed. Antonin's got a clean road in front of him. So unless Parker, his miraculously, his reinforcement learning, his steep learning network has learned secretly in the background, he's up against the very, very fast.
But if you want, also, we can probably redo it and I start last just for checking.
Okay, well, I'm going to let this, I'm going to let this one actually decide the winner, but we might do another one for fun after this.
Very good robots.
Yeah, you're both doing so well. Maxime, has Antonin finished his 3rd lap, or is this?
Yep.
Okay. All right.
Just
so, yeah, the official winner is Antonin, but we're going to have one bonus race. Antonin, congratulations, by the way. That is really impressive.
Thank you.
we are going to have a bonus race. So if the two racers could log off, in this bonus race, we're going to give Parker a 1 second head start and see what happens. Should be 1 second or half second. Well, anyway, you guys can figure it out.
I only need half.
Okay.
It's hard anyway, because I got some delay also for starting with being in Munich. So I got 200 millisecond delay anyway.
Okay. So basically, the way we're going to go right now is I'm going to say, on your mark, get set, Parker go, Antonin go. Okay.
Ready.
All right. On your mark, get set, Parker go, Antonin go. Good. Parker's in the lead. Now Antonin's behind. Now let's see what happens. Now I'm hoping that Antonin will catch up enough that he can start to see Parker and to see where that throws off his reinforcement learning.
Maxim, can you give the time of Parker to see how fast they are, or if the gap is closing?
Sure. So for the moment, you are 1 second faster a lap on the first lap.
Okay, so the gap is closing then.
Yeah, for the moment. Maybe maybe it will change.
Yeah, let's let it play out. See what happens. So basically, the question is.
Yeah, the gap is closing about 0.3 seconds.
So the question is, can Antonin survive seeing Parker, and can Antonin pass Parker?
It shows survive more scholars.
And they're both running so well. And the gap is closing slowly, but I think Antonin's starting to see Parker in front of him.
These are like getting to the limit of this track. Pretty nice.
So what will happen also is that the racing car will also slow down a bit when it has something in front of it.
I see. Okay. Which is smart from a collision perspective, but not smart from a passing perspective. So what do you think, Antonin? Do you think you'll pass him?
50-50 chance I'm gonna crash into him.
I think he's gonna pass.
Parker wipes out. And Antonin does pass and survives. All right. Bravo, everybody.
Yeah, good job, everyone.
Great race. Antonin is the victor. Everyone did really well. We will see. The next race is going to be an outdoors race to be scheduled probably, we haven't figured it out yet, maybe in the Bay Area next month. Then there will be a indoor race. I think we're actually alternating. Aren't we doing?
Yeah. Outdoor, online, indoors, and then online. The online is always a little break for us, so we can get enough money to travel again, Chris.
Okay, so we're in January right now. Outdoor is going to be February. Our next virtual race will then be March, and then we'll have another indoor race in April. If I'm not mistaken.
For those students for UCSD, if you're not aware, UCSD pay for you to travel. So you see students $500. The others, Jacob School of Engineering, if I'm not mistaken, $200 or $300, something like that. So come talk to me. We're going to try to go to the North California as many people as we can.
Excellent. Maxime, Jack, Dimitri, thank you so much. You guys are the best. This is super fun. Thank you, everybody, for joining. Thank you, our Twitch viewers. This is going to be recorded, and we'll have a link shortly, probably in a day or so that you can share the recorded video. Racers, this was awesome. See you next time. Bye all.
Great job, Chris.
Thank you.
See you.
Bye.
Maxine, I'm sticking around so we can talk.
Bye.
Yeah.